Example 3. Students are asked to count the number of chocolate chips in 22 cookies for a class activity. The package for these cookies claims that there are an average of 20 chocolate chips per cookie with a standard deviation of 4.37 chocolate chips. Part A. Based on this information, about how much variability should they expect to see in the mean number of chocolate chips in a random sample of 22 chocolate chip cookies? In part B, what's the probability that a random sample of 22 cookies will have an average less than 14.77 chocolate chips if the company's claim on the package is true? And we'll look at part C here in a moment. So part A. So based on this information, about how much variability should they expect to see in the mean number of chocolate chips in the random sample of 22 chocolate chip cookies? So the key word here is variability, right? So how do we measure variability? We use standard deviation, and this is the standard error. So the variability, again, is measured at sigma divided by the square root of n, so 4.37 divided by the square root of 22, we get 0.9317. So part B, what is the probability that a random sample of 22 cookies will have an average less than 14.77 chocolate chips if the company's claim on the packaging is true? Okay, we go ahead and draw and label a normal curve. And now we're going to use the normal CDF. Lower, we're going from negative infinity all the way up to 14.77 would be our upper. The mean of 20, and the standard deviation is 0.9317, as we already computed. You paste this in, you get 9.95 times 10 to the negative 9. Very unlikely. Again, not drawn to scale. Part C. The packaging for these cookies claims that there are at least 20 chocolate chips per cookie. One student thinks this number is unreasonably high, since the average they found is actually much lower. Another student claims the difference could just be due to random chance. What do you think? So think about this for a moment, and think about what we computed in part B. We actually computed the random chance. How likely is it that we get a sample mean of 14.77 or less, given that the mean is actually 20? So the likelihood of getting that mean of 14.77 is extremely low. It's 9.95 times 10 to the negative 9, which is about 1 in 100 million would that actually occur by random chance. So it is much more likely that the true mean number of chocolate chips is not 20 and is actually closer to our sample mean of 14.77.